Hello, everybody. My name is Covey,
My name is Cole.
And I am Vanessa.
and welcome to the
The
Couch
Couch
Potato
Potato
Lab,
Lab,
where we bring the science to you. And you may be thinking, like, "Hey, Covey, why are you at studio today? Shouldn't you be in space?" And that is correct. I am in space, and I decided to bring the studio with me up to space so we can learn a little bit more about what's in the outer world besides Earth. For today, I decided to bring some few scientists that are actually experts at space. So first, we have to my left the wonderful.
Thank you very much, Covey. My name is Cole. My pronouns are he and him. And I, first of all, want to thank you so much for taking me to space with you. I've always wanted to come to space. And, you know, on the journey, it was quite the long journey, I have to say. Through the solar system, I was looking out at all of the cool planets. And I decided, as we were going through, I figured out what planet I'm the most like. And that's Saturn. Because Saturn is a planet that has a whole bunch of rings around it, and I love to hula hoop. And I was actually 2008 local middle years hula hoop champion in the junior division. So I relate to Saturn quite a bit.
Well, since we're talking about planets, maybe I'll talk about what kind of planet I am. But my name is Covey. My pronouns are he, him. And I think the planet that kind of most resembles me would be Venus. Venus is super, super hot, and I think I am hot too. Yep, that's great. And I also saw a rabbit because in the past episode, space safety, we learned about like different equipments to use for our like soil, to capture soil and to test it. And I actually found a weird kind of like rabbit creature on Mars. And yeah, it's a weird time. Vanessa, what are your thoughts on this rabbit creature on Mars?
I kind of like it. I feel like there could definitely be a rabbit creature on Mars. But my name is Vanessa. My pronouns are she and her. And as we're going along with figuring out what planets we are, I would say that I am Earth because as a human, among all the other humans, I know the most about myself. And among the planets, I know the most about Earth. So that would be that would be who I am. And before we get into it today, we would just like to take a moment to recognize that we are on Treaty 4 land right now, which is the traditional territory of the Naewak, Nakaway, Dakota, Nakota, and Lakota peoples, as well as the traditional homeland of the Métis Nation. Please take a moment to recognize this as well and join us in acknowledging how grateful we are to share this land with those people.
Thank you, Vanessa. While I decided to take a trip out of our spaceship, and I noticed that I was like floating a lot, and I don't have any mass anymore, or something like that. Cause like on Earth, I'm like really heavy, but anywhere else outside of Earth, I'm just floating by, and like I'm very confused. But I see that you have a few things, Cole.
I do. Now, Covey, that is true. On Earth, when we are back home where we normally film on Earth, Covey is extremely heavy. And that is, I would say, 100% muscle, okay, from head to toe. He's a very, very heavy man, but it's all muscle. But it's funny that you say that you don't have any mass anymore, but even though we are in space and you might have experienced it, you're floating or you feel a lot lighter, you actually still have mass no matter where you go. What has changed, though, is your weight. And Vanessa and I are going to do a little bit of a demonstration here. A quiz for you, Covey,
All right.
to help you get thinking about mass and weight. Now, to start off, I have a package of straws here, normal straws, everyday straws. This is what I use to drink, all of my sodas with. And this is 50 grams of straws, all right?
Okay,
I'm going to
50
tell you
grams.
that straight up. This is 50 grams of straws. Now, Vanessa, what do you have over there?
Over here, I have these 3 rocks. Here's one of them. This is my favorite one. And yeah, I'll tell you just for free, 50 grams of rocks.
50 grams of rocks. Do you have a name for our special rock over there?
Melissa.
Melissa.
Yes, this is my rock, Melissa.
So Vanessa has 50 grams of rocks over there. I have 50 grams of straws. Now, my question to you, Covey, very simple.
Okay,
50 grams of straws here. A lot of straws.
got it.
50 grams of rocks over there. There's only like 3 of them.
Okay.
Not very many.
Which of these weighs more?
Whew. Okay. I know rocks are usually heavier. Like if I compare like one rock and one straw, like the rock's gonna be heavier. But I think you might be playing like mind games with me, Cole. And I think probably I'm gonna say with the straws. The straws are probably the package of straws because there's so many.
There is a lot.
There is a lot. I'm gonna say that the straws are heavier than Melissa over there.
Okay, well, we're going to put this to the test. Like Covey said, Vanessa only has about 3 rocks over there, where I probably have around 50 straws. So Covey's guessing that because I have so much more stuff here, it's going to be heavier. So I've got my handy dandy scale here. We are going to put these on, and we are going to see how much this package of straws weighs. I'm going to 0 it so that it gets back to 0, and here we go. Putting it on. Okay, so it looks like to me 49.5, so 49.6 now. We'll round that up to about 50 grams. So my 50 grams worth of straws weighs about 50 grams. Vanessa.
All right, I have my 3 rocks. I'm just going to throw them on my scale. There goes Melissa, little brother Avery, and mom Jessica. Okay, so I'm just looking around. Right here I have 50.16. I'm going to round that down to 50. So my 50 grams of rocks weighs 50 grams.
50 grams. Wait a minute. Wait. Isn't that the same thing?
It is.
It is the
Yeah,
same thing.
oh.
Covey. It is the same thing. We did do a little bit of a trick on you. I apologize. I'm a bit of a trickster. They call me the trickster of the Couch Potato Lab. And that's because, yes, we have 50 grams of straws here, 50 grams of rocks, although it looks like there's so much more straws. Because the straws have a lower mass, we just need more of them to equal out with a small amount of rocks, okay? So part of the reason that we're talking about this is because, like you said, Covey, right now we're in space, we feel a lot lighter, okay? Because we're not on Earth anymore. And do you know the thing that's on Earth that causes us to weigh what we do? There's a special name. It's a force. Do you know what it is, Covey?
Force. I think back in episode 2 we talked about it, and I think it's gravity, right? 9.81 meters per second squared, something about that.
It is gravity, Covey. You are right. So the reason that we weigh a certain amount on Earth, our weight is always determined no matter where we are by the force of gravity. So our mass is never going to change. If I am on Earth, if I am on the moon, if I'm floating in the middle of space, our mass is always going to be the exact same. What might change, though, is our weight, because the weight is calculated by the force of gravity that's pulling us down. Now, you mentioned that number, 9.81 meters per second squared. That is the acceleration at which we are pulled down towards the Earth. That's the acceleration of gravity on Earth. But that number is going to be different depending on where we are. So I'm going to do another demonstration, okay? And I don't want this one to be too tricky either. I am a little bit of a trickster, like I said. But I have a question for you. Vanessa, you can chime in too if you'd like.
Okay.
I have 2 objects here, 2 simple objects. An apple. This is actually a space apple that we picked on Mercury on the way over. And a hammer. This is just a regular hammer, not a space hammer. So we've got a hammer and an apple. Now, I'm going to hold them at the same height, and I'm going to drop them to the floor. And all you have to do is answer this question. Which one will hit the ground first?
Ooh, Vanessa, what do you think?
Very simple.
When I hold the apple and hammer in my hand, when I did that earlier, the hammer is heavier in my hand. I feel like it'll go faster because it weighs more to me. That's my guess.
So
Hammer
you're gonna
first.
say hammer?
Yeah.
All right. I think it's going to be the apple, because remember when chickens were very little, they thought that sky was falling, and it was actually an apple. And I'm pretty sure it's the apple.
Okay, so 2 different guesses here. Vanessa's going to go with the hammer. She thinks the hammer's going to hit the ground first. Covey is going to say the apple. So I'm just going to hold them over the table here. I'm going to make sure that I get them at the right height. And again, I'm going to drop them, or try to drop them, at the exact same time. And I want Covey and Vanessa, I want you to watch really, really carefully at which one hits the ground first. Okay, here we go. I'm going to drop them in the count of 3. 3, 2, 1.
Oh.
So which one was it? Did you see?
They're the same. I think they dropped at the same time.
So we're
Covey, you
both
are
right.
exactly right.
Oh,
They
nice.
hit the ground at the exact same time. So although, like Vanessa mentioned, when she was holding both of these objects earlier, the hammer does feel a lot heavier. It might have a bigger mass. It doesn't actually matter, because the force of gravity is going to act upon things in the same way. We talked about that number, 9.81 meters per second squared on Earth. That force, that acceleration, is going to be experienced by all objects, no matter how big or how small they are. So that means if we were in a perfect vacuum, which means that there was no air resistance, which we kind of are here in this spaceship, all objects are going to hit the ground at the exact same time, because they are all moving at the exact same speed through that same acceleration of gravity. So that's how gravity works.
So that is why I am floating around when I get to Mars or different other planets as well. And gravity is a really big thing, and gravity is like very, very important in like some crazy things. Oh, like that thing. Oh my God,
Oh,
is that a
no.
black hole?
Oh
Oh,
no.
no.
That's a black
It's
hole.
coming straight for our
Oh my
ship.
God, what do I do, Vanessa?
Thank goodness I'm an expert on black holes.
Oh.
So, yes, what is a black hole? We're wondering. We don't know. It's over there, but maybe it won't come for us. So, black holes are one of the most powerful forces in the universe. It's where gravity is so strong that nothing can escape it, not even light. That's why it's a black hole. You'll be able to see a picture soon of a black hole. Yeah, there it is. So you can actually, we know that that's a black hole. You can see it, and it's because black holes are invisible. We can't see the actual black hole itself because they don't reflect any light, but scientists know that they exist by observing light and objects around the black hole, which is why we can see the ring around the black hole, but not really the hole itself. So strange things are always happening around the black hole, but how did they get there in the first place? So black holes are formed when giant stars explode at the end of their life cycle, and that explosion is called a supernova. If a star has enough mass, it will collapse in on itself down to a very small size. That happens when its inside fuel burns out. Okay, so due to the small size and enormous mass that the black hole has, because it used to be a giant star and then it gets really, really small, the gravity is so strong that it will absorb light and all the objects around it, even stars sometimes. And yes, we'll be able to see a special part of a black hole right here of the event horizon. It's a GIF, it just should loop, I think, and it's the special boundary around the black hole, and that's the event horizon, and it's the point that everything, even light, once it goes past there, it can't come back. Yeah, so once it's that line kind of sort of in the middle and all around, it's the light that you can see. Once you get past the event horizon, you cannot come back. That's when Covey predicted earlier today that it would, you'd turn into spaghetti, which is true, because all your atoms would get pulled apart because the gravity is so strong. And we're going to be able to demonstrate kind of what happens to a star during the supernova right now. I have to blow up this balloon, though, so you two are going to have to give me some opinions on black holes.
Well, I will say one thing. I was looking at that video of the event horizon. That looks pretty scary. And I mean, if this black hole that's coming towards our ship is any indication, I'm not into being pulled apart into spaghetti. Okay, I'm not a big fan of that. I would prefer to be turned into a penne noodle, if anything.
A penne noodle.
Why a
Because they're
penne
little
noodle?
bit- because they're pointy, and
Okay.
I feel like I could, defend myself from potential enemies with those points that are at the end of penne noodles.
That's a good one.
Yeah.
But yes, I got my balloon all blown up. Thank you, Cole.
You're welcome.
But we were talking about penne noodles, and what would we be like if the black hole sucked us all in? And I would be spaghetti, because spaghetti is a great meal, and Cole decided that he would be penne noodles.
I would be penne. Yeah,
Penne.
penne lane, as they say.
Oh.
But Vanessa, you're working on quite the contraption over there.
I sure am. I'm still making my star, some would say. Just reminds me of you, Cole. You got that star quality.
Oh wow!
Yep.
Thanks. That's the first time anybody's ever said that about me.
Hey,
That's
it's-
actually it took you, so long, this long journey out to space.
Yep.
You haven't really talked to me.
To
But
realize.
I appreciate that. Appreciate
Vanessa, what's that term called when a star explodes again?
That's a supernova. We're actually going to
Supernova.
create a supernova right away here. So it's going to be
Ooh,
quite
exciting.
the exciting thing down here at the Couch Potato Lab. I think I'm ready to make my supernova. So this will be our star. It's our balloon with some tinfoil just wrapped around it. I used some tape just to secure it, so if you're following along, I feel like that would be pretty useful just to hold everything together. So this is our star. It has its own fuel inside. That's like the air that I blew into it. It's its fuel. So if I push on it, it doesn't explode. It doesn't compact. It's fine. It keeps its shape. It's doing all right. That's because of the fuel that it has inside of it and the gravity that my hands are the gravity. So my hands, when I push on it, the gravity is fine because there's fuel inside. So with a supernova, the star runs out of fuel. So there'll be no more balloon. I have to pop it, so it might be kind of loud. Close your ears in the studio.
Oh, jeez.
There we go.
Big
So-
explosion.
Even though, yeah, it was a big explosion. Maybe that's how they sound. We don't know.
A balloon pop.
So our balloon or the star fuel, it's gone. See you later. And now we have the star with no fuel. So when gravity goes to push on it and exert its force on it, what happens will be
Whoa.
it's such a small size now, but it's still, all the gravity is still there, it's still pushing. So that is what our black hole would become. It goes from really big to really small. And imagine this on the scale of like kilometers, millions of kilometers wide stars, like the sun, if the sun were to do this, and it would get really tiny. And then that's the black hole. It has so much gravity, and then everything would come in. So maybe, should we see, I'll throw it at the black hole that's over there, and then maybe it'll cancel out.
Yes, double
that's
black hole.
that makes sense to
Okay.
me, yeah.
What do we think? Yeah?
Sure, just give it a
Yes.
toss.
Give me a little countdown.
3, 2, 1.
Pew.
Great.
Oh,
Look,
there it goes.
there it goes. See you later.
Oh, see
I
a
don't
black
think
hole.
anything happened. I think we need to keep going. Pew pew. Pew.
It's been nice knowing you.
And let's talk a little bit more about space, because space isn't a flat area. It's actually curved. And in order to kind of demonstrate this, we're going to get right into our activities. We're going to use a polyester bed sheet, and that's nice and stretchy. You're also going to need something a little bit like a round, heavy object. And today we're going to use an apple. And also some light round objects like marbles or ping pongs, and those are going to be our planets. And last thing you need is a helper. You need at least about 2 people to make this activity happen. And I'm going to get our scientists to come out to the front, and we're going to demonstrate how space works. So the first step is to
Did
lay
you take
out-
these from my bunk?
Yes, how'd you know?
Kobe.
You know, just yesterday.
Okay, so we're supposed to hold it like this, right, Kobe?
Yes, we're gonna hold it, and you're gonna make it as tight as you can.
Okay.
Perfect, just like that. And that is pretty much space. So if I had a
That's it?
planet, that is
Okay.
space.
Alright.
It's space time. If I had a planet, and I'm going to represent this planet with a marble, right? If the planet was going through space or orbiting around, what direction did it go through?
Whoa, it
Just
fell
straight.
right out.
It went straight, right?
Yeah.
Fell out
But
of space.
Do planets usually move through space in a straight line?
No.
Not that I'm pretty sure they like kind of move. They move in a shape that's kind of like a circle.
Yes, yes,
Yeah.
and that is called orbits. So like the moon orbits around the Earth, and the Earth orbits around the sun.
Mhm.
And we're going to represent a sun by using an apple, because a sun is a planet or a star. Pop quiz.
Star.
Planet. Oh.
It's a star. So the sun is really, really heavy. It has a lot of weight, and there's lots of gravity acting upon it. So I'm going to put this apple right in the middle. And what do you notice?
Maybe we should move this down a little bit, Vanessa,
Sure.
so everybody. Or I don't know if that helps. There, we'll just do this. This is good. Well, what I noticed, Kovi, is that when you put the apple down there, the bedsheet started to kind of sink, like it curved.
Yes, exactly. So there's a big dip when I put that apple there, because the sun is really, really heavy, hey? And what happens now is that space is actually curved. There's a little dip around that. So when planets move around the Earth
Oh.
or the sun,
There we go. Our sun's floating away. There we
let's see what happens.
go. Oh,
Oops,
Oh.
let me try again. Lots of marbles.
whoa. It was moving around it.
Yes.
Oh.
That's super cool. So instead of going straight across like
Oh.
last time, it kind of moves in a little bit of that orbit shape that you were talking about. Oh, that was a good
Yes,
one.
exactly. So it's kind of in a circular shape or motion now. So that's it orbiting. And what do you notice when the marble is a bit closer to our mass or the sun?
It almost looks like the closer it gets to the apple, the faster it's moving.
Yes, and Vanessa, how about if it's farther away from the sun?
Maybe if you move your right hand, there we go. Maybe that helps.
Yeah.
I don't know if that helps.
Oh, yeah, there we go. Yes, when it's farther away from the sun, it goes a little bit straighter, and it's a little bit slower.
Yes, it's a little bit slower. And this is because of the gravity on the sun, it's actually pulling the planets closer to the sun. So if it's closer, gravity is acting upon it. It's going to speed up when it orbits around the sun if it's closer. And if it's farther apart, then it's going to act a little slower. So let's say I have Earth right here and Mars. And Earth is a little bit closer to the sun. So I'm going to put the Earth a little bit closer right here. And this will represent Mars, which is a little bit farther. And if I move them,
Oh.
which one orbits faster?
Do that one more time, Kobe. Oh, sorry.
Huh. I think Earth goes a bit
It
faster.
looks like Earth was going a little bit faster there. Yeah.
Yes, exactly. So Earth rotates around the sun. For how long does it take for the Earth to
you know this
fully
one, Vanessa?
orbit around the sun?
I feel like a year.
A year.
Yeah.
Yes,
Whoa.
365 days.
Okay.
Mars, on the other hand, it actually orbits around the sun a little bit longer, so maybe twice or 3 times more. And that's because Mars is actually farther away from the sun. And how about a black hole? What do you guys think?
What's the question?
So
What a
what
black
if the black hole was right in the middle there?
Well, I think that if a black hole just opened up in the middle of the solar system, like on top of the sun, it would be like this.
And the sun's gone. All the
sun's
planets are gone.
It would swallow everything up.
That black hole would just suck everything up, just like I did to that apple.
There you go, and it would be no longer there. It'd disappear
Folks,
in a
come on.
blink of an
That'd
eye.
be great.
That's crazy. So you can try this out at home and send us your pictures and how that went, and see how the planets orbit around the sun. And another way to demonstrate this is with little robots that we brought onto space. And Vanessa, I see those little robots right now are with you, hey?
Yes, I have one just right here with me. They're called Autobots. They're really awesome. They can read colors like a code and then follow whatever you tell them to do. But first we need to learn about what we've got right here, which is kind of how the moon goes around the Earth. So right here is an ellipses. It looks like a circle, but kind of more flat, you could say, stretched out a little bit. And just like a circle, if the ellipses was all on its own, then the center of gravity, so where the strongest pull would be right in the middle. Right in the middle. I think like about there.
Mm-hmm.
So if that were the case, then the moon would go around the Earth in the middle. But we actually have this huge thing called the sun. I'm sure you've all heard of it. It's really, really big. It has a huge mass, so it has a strong gravitational pull because it's heavier. So that shifts the Earth out of the middle of the ellipses to a little bit over to the side. So what do you two think? When the moon is going around, do you think it will be slower or faster as it gets closer to the Earth?
When the moon is closer to the Earth,
Yes, will be slower or faster.
I think it will be faster. How about you, Cole? What are your thoughts?
I agree. I think it'll be faster, and I'm just thinking of the last demonstration that we did that showed like when Earth was closer to the sun, it was moving faster than Mars, for instance. So I think the closer the moon is to the Earth, the faster it will be moving.
I think you're right. Let's take a try. I'm going to put it right here so it's starting far away. And it'll go around.
Whoa.
Reads the code. The next one gets a little faster. Oh, really fast. Oh, a little slower. And
That
even
is
slower.
fascinating.
Yeah, so there it goes. It keeps on going. Look at that. So it's very nice. That's how our moon goes around our Earth. It just gets faster and faster.
So talking about moon orbits and all that, how do eclipses work? Vanessa, do you know by chance?
That's a really good question. So if we just give it a second, it'll get back so that it'll be, our Autobot will be in between. So if I'm shining a light from like here, right there, the moon or our Autobot would have been blocking the Earth. So if we have a moon in between us and the sun, we're not going to be able to see the sun super well. So that's what happens with a solar eclipse because the sun is blocked. So there's a moon, or our moon is in front of the sun, and then we can't see it. It looks like there's the sun and then the moon's inside, so it kind of looks like there's a nice ring around the sun. What else happens, a fun one, which is called a lunar eclipse. If we watch our Autobot friend here, when it gets to right about there, it will be in the shadow of the Earth. So in a lunar eclipse, the sun, or I guess the moon would be being blocked by the Earth, so it can't get anything from the sun, and that turns it red because it's in the shadow of the Earth. They're kind of, it depends where you are on the Earth, but they're common-ish. For yearly, there's about 2 or 5 of each, but you can't see them from everywhere in the world, so sometimes there's really good ones that come over us in Canada. We can see them really well. And yeah, that's our eclipses.
Ooh, I know that there's a upcoming eclipse happening. Hey,
Whoa, really?
yeah, I think is it December 14th of this year?
Yes.
December 14th, 2020. There's
Yes.
going to be a solar or lunar eclipse.
I'm not
Oh,
sure.
I think it was
It's-
solar.
I think one of the eclipses, and that'd be cool. I think it's happening around Brazil, correct?
Yes,
Oh, cool.
lower in South
Wow.
America.
I think a vacation is in order for us three. As soon as we get back from this space trip, we're going to head over to Rio.
Oh, Cole, look at that.
Yeah, what's
it's
up?
so nice.
What are we looking at?
We're looking at the stars, bro.
Oh, yeah.
Yeah, they're so nice. Like, I wonder, do they just like supernova and become a star, or like how
You
does
know,
that work?
It's
Reverse.
really interesting, Kobe. It's really, really interesting. Sometimes we get so caught up in all of the science that we're doing here in our lab on this spaceship / studio that we forget to sometimes, slow down a bit. You stop and smell the roses or smell the burning hydrogen, as it were, that's out there in the cosmos. Because stars are really, really interesting. And Vanessa talked about black holes earlier, and she mentioned supernovas and all of this different types of stuff. But what you might not know is that stars have sort of a life cycle, kind of like we have a life cycle, or plants or animals have a life cycle. Now, all stars, and we're going to put up a graphic here, we can see all of the different types of stars here. All stars start as something called a stellar nebula. And a nebula is like this big cloud of dust and gas that swirls around, and it's usually really, really cool colors. It glows purple or orange or pink. And from there, what's going to happen is we see two specific timelines that progress on from there. So we've got the top line and the bottom line. Now, the first thing that happens is when a star is born or formed, it either is going to become an average star or a massive star. Now, you can sort of think the difference between average star and massive star as like the difference between myself and Covey. I am an average star where he is a massive star, not only in star power, personality, charisma, but also, like we mentioned, he is absolutely jacked.
Oh, you're too nice.
Head to toe muscle. There's not, his bones are muscle, it's all muscle, folks.
know
So
it.
an average star and a massive star you can think of as a massive star is just really, really big, and an average star isn't as big. An average star, for example, our sun would be considered an average sized star. So it's really, really big from what we can tell and relative to things that are in our solar system. But if we think of the entire universe at a grand scale, an average star is actually really, really small. The sun is actually one of the smaller stars. So there's lots of bigger stars. So from there, whether we become an average star or a massive star, the next stages are either red giant or red supergiant, okay? So as the star ages, it's going to first change color and start to glow red. And if it was an average star before, it's going to turn to a red giant. Or if it was a massive star, it's going to turn into a red supergiant. And again, the difference here is just how large the star is. Average stars turn into red giants, which are bigger than average stars, but massive stars turn into red supergiants, which are really, 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 really big, okay? So the life cycle is progressing. We are moving older and older and older into the star life cycle. Now, if we bring up the graphic again, we're just going to follow the top line now. So after a red giant, what ends up happening is we follow that top line. The next step is called a planetary nebula. And again, the star is going to start to break down, and a lot of the gas and the dust that was contained inside is going to disperse and form one of those nebula clouds again, until all that we have left at the very, very end of the top line of our diagram is a white dwarf. So if we look at the picture, first of all, the star has changed colors. It's not as vibrant anymore. It's a lot smaller as well. So that's why we call it a white dwarf, because the size of the star has actually shrunk quite significantly. So these white dwarfs are really, really small. And basically all that we have left is the inner core of that average star from a long time ago. So that ends that first top line life cycle. But if we go back to the bottom line, after a red supergiant, what could happen after we get to a red supergiant, after enough time passes and the star gets big enough, is, like Vanessa was talking about before with the balloon pop, we get a supernova, which is this gigantic explosion of the star. And after a supernova happens, there's actually two different options that might happen. So the first is we get something called a neutron star, which is like a really, really dense core, kind of like a white dwarf. And the other option, which is like a cool option if you ask me, is what Vanessa was showing before, and that's a black hole. So sometimes if there's enough energy released, and enough matter collapses, you will get a black hole, which we already talked about is something that's so massive that even gravity, and it has so much gravity, that even light cannot escape. So when we look into the night sky and we see all of these different types of stars, we're actually looking at a lot of different stages of that life cycle. Some of the stars that we see might be red giants, or just average stars, or massive stars. Now I have a question though for Covey and Vanessa here.
Okay.
So I said that the sun was an average star. Okay, so it would be an example of an average star. So if you were to predict millions and millions and millions and millions of years into the future, what do you think is eventually going to happen to our sun if it's an average star? Now, if we can bring back the graphic if you want to see, if you want to just check
I remember
what the life cycle is. But if our sun is an average star, what do you think it's going to end up being? Vanessa, you have the answer.
Yes, I think it'll be a white dwarf eventually, but it has to go become a red giant and then a planetary nebula, all that jazz. I bet that takes quite a while, hey?
It does take a long, long time. So yes, our sun will eventually expand, become a red giant, and then collapse again into a white dwarf. But this is something that's going to happen like millions and millions of years from now. So we don't have to worry about it quite yet. But when it does become a red giant, what we have to understand is it's going to get really, really big. So we talked about, things that have larger masses actually exert more gravity. So how would that change our orbit? How would that change how hot it is on Earth? All of these things, people millions from years now, well, they will have to take into consideration. But thankfully, we don't have to worry about it.
For now.
Oh, that was ominous. Ominous.
We'll see what happens. Wow, stars are beautiful. They twinkle in the sky, and then we see it as like constellations and stuff like that, and like a wishing star as well. But sometimes these wishing stars are like mistaken as for comets, and comets are actually like big cosmic snowballs that are made out of different things like dirt and sand and gases, and it's really, really, really cold. And today I'm going to make a comet with dry ice. And dry ice is one of my favorite things. Can anyone guess what its freezing temperature is? Or it becomes a solid at what temperature?
I don't know. Do you know, Cole?
The freezing temperature of dry ice is 1 degree. I'm doing Price is Right. If I say 1 and everybody else is over, I win automatically.
1 degrees. Not quite, because we know that water freezes at 0 degrees, right?
Darn it.
So it's actually -79. So anything below -79, it's actually dry ices can be formed. But once it hits over -79 degrees, it starts to sublimate. And what sublimates means it skips the liquid phase. It goes from solid to gas real fast.
Oh.
Yeah, so that's how dry ice is going to work. But let's talk about what the comet is made out of. So here I have a bowl where I'm going to make my comet. And comets are made out of water. And I'm going to pour about, let's say, 1 liter of water.
That's a lot of water.
Lots of water, because comets are pretty much water, rocks, sand, and a few other things.
What's your favorite thing that's in it?
My favorite thing?
Water, rock, sand, or the other thing?
The other things. Well, the next thing, dirt, right? Because comets are usually very dark in color, like maybe black or dark brown. Ooh, nice, love that. And I'm going to mush it up, and then we're going to see what this looks like eventually. But it looks beautiful at the moment. Next thing I'm going to add is cornstarch, because comets actually have organics as well. And this cornstarch will allow this comet model to stick together. Yes. So 1 tablespoon of cornstarch, and corn syrup is going to do the same thing as well. It's going to help the comet stick together. Ooh.
Nice.
Love that stuff. You find it in candy?
Oh, yeah.
Good times.
Oh, yeah.
And the last thing it has is alcohol. So the alcohol that's in comets are actually called methanol.
I have scissors if you want.
Whoa.
Okay, I need scissors.
Yep, there you go.
Thank you. All right, and about a tablespoon of alcohol. Nice. Yeah, so it has organics. Comets also have amino acids. So we have amino acids as well. And Cole, can you remind us what amino acids are again? They're like the building blocks of...
Yes.
Of...
They are the building blocks of proteins. Now, proteins, you might have heard of before that we need to eat foods that are high in protein because it'll makes us strong, like Covey. But proteins, that is true. Proteins are also just things that our cells make. They're little machines that do jobs. So we have proteins that will do some pumping inside of our cells. We have proteins that build DNA. We have proteins that do a lot of different things inside of our cells. So what is crazy for me to think about is that amino acids are in our bodies, but also the same thing is in comets that are floating like and flying through the sky like millions of miles away. I can't believe that.
I know, right? All right, let's take a look at the color of this comet. Brown.
Yeah, wow.
Wow, who would have expected that?
Appealing.
Okay, the next thing is that comets are made out of really, really cold gases and frozen things, and I'm going to represent that with dry ice. So I mash it up with a hammer. I'm going to dump a lot, about like maybe 5 pounds of dry ice in here.
Whoa.
And woo.
So Covey, is that the sublimation that you were talking about
Yeah,
earlier?
so this is what's happening here is that the solid dry ice pellets are converting into gaseous. To
Is it
gases.
bubbling?
It's bubbling.
Oh, I can hear it.
Ooh,
That
chilly.
is pretty spooky, I have to say.
Should I add more? Why not?
Yeah, why not?
Why not, eh?
Whole thing.
Oh, that was a big chunk.
So as it's forming, you can see that there's a lot of gases that are really, really cold. And eventually what happens is that this comet is usually kind of orbits around the sun as well. And while it orbits around the sun, solar wind is going to blow against this comet. And you can see that tails are formed. And what the tails are pretty much just like streams of this gas. And I'm going to wrap this up together.
Good thing you're wearing those gloves.
Oh yeah, safety first, hey?
What is going on?
It's a cool sound.
Squeezing some gas out of there?
Ooh.
Whoa.
I can feel a little breeze over here.
I know, right?
Oh, yeah, a little bit.
It's a little
Yeah,
bit
it's
chilly.
Feels nice on a hot day because we went to Venus. We passed by Venus, and Venus was
That's where you saw the
real
rabbit.
hot.
We forgot to
Yes.
install AC in this spaceship.
Oh,
We
it's
should
terrible.
have followed that Couch Potato Lab episode where they made it with all those 2-liter bottles.
Oh, we should have.
Darn it.
All right, let's take a look at our comet.
Whoa.
Wow.
Whoa.
Our comet.
Covey.
This is our comet. So this is a piece
Wow.
of a comet. I got lots. Let's take a look.
Oh. That's a
Yeah.
big comet.
So
That-
there's
Yeah.
a lot of comets and many love that, very good aesthetic. There are a lot of comets that astronauts have found, and another example of a comet that we have found and named is called the comet Borrelli.
Borrelli.
There
Oh,
it
look at
is,
that.
and
Looks
it's
just like
named
it.
after Alphonse Borrelli, who actually found this asteroid, and I mean the comet, and named it after himself.
Does it kind of look like an upside-down bowling pin to anybody else?
Yes, like half
Yeah.
of it. Yeah.
Yeah.
Maybe I don't know, what does this look like, Cole?
What the one that you made?
Yeah.
It looks like when you make macaroni and leave it in the thermos for a long time, and then it comes out as one big chunk.
I love mac and cheese. It's my favorite. Maybe I'll name this Comet Covey.
Yeah, that's a good
Yeah,
name. That's
I
a good
love
name.
this.
That's a good one.
So good. All right, and yeah, so that's how comets are, and it's a great time. I thought of making an edible model so that I could surprise you two, but I
Aw.
decided not to because I'm not feeling it today.
Oh, well, that's okay.
Thanks for the thought.
That is very cool, Kobe. Though I do love a good comet.
Me too.
Comets are great. All right, now that we talked about stars and comets and all of that, what is the coolest thing I would say in space are the different planets around, right?
Oh.
And it's so cool seeing them. I think it's time for a little competition to see who knows comets a little bit more. And it's time for a science showdown here. All right, so how this science showdown is going to work, I'm going to show them a picture that ICE headquarters has found of the planet, and they also found a little bit information about these planets as well. So once we show that, then our scientist over here can read over the clues and the picture as well and buzz in their answer to see if they know what planet is what. And some may not even be planets.
Oh,
Whoa,
that's
okay.
tricky.
Oh, so it's gonna be
Okay.
a little tricky here.
Ooh.
All right, and the winner, winner gets to dare the loser to do something.
Oh, okay.
Why not?
Sure. All right. There's some
Challenge
stakes. I like
time.
it.
All right, the very, very first planet for our science showdown is this beautiful, beautiful blue planet. It's about more than 30 times as far from the sun as Earth, and the only planet in our solar system not visible to the naked eye. Ooh, it's about 4 times wider than Earth. The atmosphere is made out of mostly molecular hydrogen, atomic helium, and methane, so pretty much just gases. And it has at least 5 main rings and 4 more ring arcs, which are clumps of dust. Ooh, I heard the moo first.
The moo.
Okay,
The
Cole.
moo is me.
What do you think?
I'm actually not super confident, but my finger slipped, and now I'm kind of have to go with it. I am going to guess that planet is Pluto.
Pluto. All right, good guess.
Pluto?
Vanessa, what's your guess?
I think that is Neptune.
Neptune.
my
How
guess.
confident are you?
79% confident.
79%. And the correct answer is Neptune.
Oh.
Nicely done, Vanessa.
Pluto's not even a
Nice,
planet
nice,
anymore. I don't even
nice.
know why I said that.
Yeah, so he said there
Brutal.
would be some that aren't planets. So
Brutal.
Yeah, so
trick
maybe.
question.
The next one is a fan favorite, and it's one of the largest planets in the solar system. It's more than twice as massive as all the other planets combined. It's 5th in line from the sun. It has stripes and swirls. Ooh, and look at that. It has a little birthmark. It's red. A great red spot. Oh, I heard the moo first, Cole.
Y'all, you're always gonna hear the moo first. So they don't call me fast fingers for nothing. I know that one because that's right beside my favorite planet. That is definitely Jupiter.
Jupiter. Oh,
Jupiter.
all right. Vanessa, do you agree with Cole's guess?
No, because it's red, and I know that Mars is red, so I think it might be Mars.
You think it's Mars. All right, and the correct answer is Jupiter.
Yes.
Jupiter.
Lovely.
There it is.
I did
Jupiter.
it.
It is Jupiter. So that great red spot, it's pretty much like a raging storm that's been happening for like over hundreds of years.
And did it say that it was bigger than the entire Earth itself?
Yes.
That's how big Jupiter is that one small storm is bigger than Earth. Okay,
It's as
great.
big as Earth, bigger than Earth. It's crazy, crazy. All right, here's the third planet. It's going to be a great one. Might be really recognizable to some of you guys are here.
Oh.
All right, this sixth planet
Oh.
from the sun and the second largest planet in our solar system. It's not the only planet to have rings. It's made of chunks of ice and rock. It's also considered a gas giant like Jupiter. So hydrogen, helium, and that's what it's made of. But I gotta notice that nice ring. Ooh, put that ring on it. Any guesses? Yes, Vanessa.
My guess is that I don't really know what planet this is, so I'm gonna guess one that we haven't talked about yet. I think it might be Mercury.
Mercury. Ooh, good guess, good guess. Cole.
You'll notice that I didn't even have to ring in that time because I was so confident that Vanessa would get the answer wrong. That is none
Ooh,
other
shots
than
fired.
the greatest of planets, the crown prince, Saturn.
Saturn. And the correct answer is Saturn. Nicely done, Cole. All right.
Yes.
All right.
Wow.
All right. Okay, Vanessa, you got time to redeem yourself. No
I hope
worries.
so.
All right. The next one, the fourth planet, it looks a little red to me. It's a dusty, cold desert world with a very thin atmosphere. It has lots of polar ice caps and weather and canyons and volcanoes. Ooh, very, very cool. It's a rocky planet with, again, volcanoes. Any guesses? Ooh, I got
Okay.
the horse.
So I thought that it might be Mercury again because it's red,
Mm-hmm.
but I saw that the polar ice caps were on there, and I know that Mercury is pretty close to the sun, so it couldn't be that. So the other red planet is Mars. Is it Mars?
All right. Good guess. Good guess.
Okay.
Cole, what do you think?
Well, I know that there was a movie that came out recently where somebody was trapped on this planet and he had to like make a greenhouse and grow his own food and stuff like that, but I never did see it. So I'm going to guess whatever planet was in that movie.
All right. Vanessa, do you know what Cole's talking about?
Mars again. I think I just
So
must
what
be
is
right.
it? What is it?
All right, and the answer to that planet is Mars.
Cool. I'll take it.
Nice, very, very good. All right, point to both of you, I guess.
Sure, I'll take a half
Yes,
point.
yes, half point for
okay.
Cole because he didn't really get the name of it, but he can redeem himself again through
Beautiful.
this fifth planet. that could be a planet. I don't know if it's actually a planet or not, but we'll see. Next planet is this one, the second planet from the sun and our closest planetary neighbor. And closest planetary neighbor means Earth. It's very close to Earth. This planet spins in the opposite direction than most other planets do. Wow, I wonder what it is. And it's also really, really hot. Oh, I heard the moo.
Well, you said it's the closest thing to Earth, so it has to be the moon.
Could be the moon. But this one said it's really, really, really hot because of the greenhouse effect.
Well, I've never been to the moon, so I am no person to judge whether it's hot or cold.
Well, we're going to the moon in like a couple days, so.
Well, we're about to find out then.
All right, Vanessa, what's your guess?
I think that one is Venus.
Venus.
Oh yes, I
Really?
forgot. They're planets.
Yes, and
Right.
the answer to that one is Venus. Very good,
Mm.
because
Ooh.
Venus is super, super hot, like me. You know it. All right, this is the last one, so maybe we'll
Oh.
do winner takes all.
Sure,
for this
yes,
Oh,
one.
I'm down.
Hey,
okay.
hey. All right, so the last one is only about half the width of the United States. The atmosphere is very thin and is composed of nitrogen, methane, and carbon monoxide. Ooh, it's super, super cold, negative 232 degrees Celsius, and has a heart-shaped glacier. Oh, look, it's considered a dwarf planet. Oh, I heard the horse first, Vanessa.
Okay.
Vanessa, can I make you an offer?
Sure.
I think we should say it together
All right.
because I can't handle defeat. And if you get it right and I'm second, I don't know what I'm going to do. So I
Okay,
think
fine.
we should try to say it together.
And then if we both win, we can dare Covey.
Yes, that's right. This is perfect.
No,
okay,
this
awesome. All right.
backfired. Oh,
okay,
no.
on the count of three, we're going to say it at the same time.
Okay, here we go.
3, 2,
2,
1.
1.
Pluto.
Yes. Yes, Covey, you're going down.
Show me the money.
And the winner.
Show me the money.
Yeah, it's Pluto.
Yes,
oh, wait,
sir.
not that Pluto. It's Pluto. Ah. Very good.
We
It
did
is
it.
Pluto, the dwarf
did it.
planet. Very good, guys. Nicely done. Unfortunately, because they kind of tied and there's no loser, I guess I'm the loser. So what's your dare?
I think you should eat something on the table right now. Maybe a spoonful of cornstarch. What do you think, Cole?
I was just going to say, I dare you to compliment me. Because he very rarely does. But I like this too. Let's do it.
Sounds good.
If you feel comfortable.
Yes. This is a very sanitized
Definitely
Yes.
a normal thing.
measuring.
right now.
Yes,
spoon.
delicious.
I cleaned it before.
Bottoms up.
Bottoms up. Here you go.
Wow. That was
What is it? What does this taste? What is this?
astonishing.
All right. Well, that was great. Let's move on. Since we were talking about black holes, there's one person that I think needs a little STEM spotlight, and it's going to be a great one. So here is our STEM spotlight for today.
On today's STEM Spotlight, we want to introduce you to Dr. Katie Bowman. Dr. Bowman was a PhD student in computer science and artificial intelligence at the Massachusetts Institute of Technology in 2019 when she led the creation of an algorithm that would eventually lead to an image of a supermassive black hole. Whoa! So the first ever image of a black hole was discovered by Dr. Katie Bowman. Great work, Dr. Bowman.
Yes, Dr. Katie Bowman. She was part of a cool organization, cool company, when she was 23 years old. I'm almost 23, and I
Wow.
never did anything just as amazing as she did. She had cool telescopes, 8 of them, and she saw a picture of the black hole, and that was seen last year, which is crazy to think about.
Super.
I know. All right, it is time for our favorite segment, Ask Our Scientist. Thank you again for sending in all your questions. I'm very excited to get to each one of them. The first question comes from Gabe. Are sinkholes the same as black holes? All right, Vanessa, since you're talking about black holes the entire episode, what is the difference between the two?
Okay, so a sinkhole, I totally understand where your confusion might have come from, Gabe, because on Earth, if a sinkhole happens, all of the ground just collapses in. If there's a car there, it falls in. The people fall in, trees fall in, all this kind of stuff. I totally see what you mean. But that's just a little area on Earth where it falls in. Now, a black hole is in space. I guess it could technically happen on Earth, but probably not. But it's in space, and it's that a star collapses in on itself, and then it's the gravity that makes it that makes it a black hole. And it's the gravitational pull and all the things that suck in the light that make it a black hole. So yes, it's a space causally disconnected from the rest of the universe. So it's barely even part of the universe.
So Vanessa, quick question: would you rather fall into a sinkhole or a black hole?
How deep is a sinkhole?
Good question.
I don't know. Could be.
I don't know.
50 meters.
50 meters? Okay. I feel like things wouldn't end well for me either way. Maybe I could take a camera with me or something in the black hole, and then we could figure out what would be in there. So I would like to go into a black hole.
Oh, brave answer.
Thank you.
All right, the next question comes from the Hayes brother. Fun fact, by the way, do you know the lightning is 5 times hotter than the surface of the sun? Wow, Cole, what degrees can it get up to?
That is a very fun fact, Hayes brothers. You are correct that lightning is very, very hot. We think that the sun is pretty hot, but lightning is actually even hotter. Lightning burns, or not burns, but lightning, when we have a strike of lightning, it's around 50,000 degrees Fahrenheit, which is very, very hot. And fun fact about lightning, there's so much energy, so much heat that's produced when a lightning strike happens that it's actually one of the only things that is able to have enough energy to break a nitrogen triple bond.
Oh,
okay, that's right.
Some
Yeah,
chemistry down
nitrogen
here.
triple bond. So imagine there's an N right here and an N right here, and my fingers are 1, 2, 3 bonds. Okay, that's very, very strong. All right, that's like almost as strong as the bond that I have between me, Covey, and Vanessa. Okay, so this bond is so strong that most things in nature can't break it. But when there's nitrogen in the atmosphere and there's a big lightning strike, it's actually able to break those nitrogen atoms apart, and then plants can use them, and then we can eat the plants, and then we can have a good time. So you're right. Lightning is pretty crazy stuff, and it is very, very hot.
Oh, nice. Thank you, Cole. Lightning is super, super hot. Our number 4 question from Eli is the couch potato okay? The one on the left side. Why is he growing hair on its body? Vanessa, why?
Oh,
Is
Lord.
this one potato, Covey? Is this potato?
Yes, that's potato
Okay.
potato.
So potato, like the rest of potatoes on the earth, they want to make more potatoes. I think these are the eyes of the potato. Is that? Yes, thank you, Covey. So potato is trying to get more potatoes into the earth, trying to grow more for us. So that's the beginning of a long tube that's going to go. If potato was in the ground like it is supposed to be, then they would have grown a long tube, and then more potatoes would have been able to grow from that tube underground, and then we'd get lots of potatoes. So potato is okay. Sorry, potato. I hit off a little hair, but yes. So these are the eyes of the potato. It's doing its job. It's all good. Thanks for your concern, Eli.
All right, thank you. Eli, you also came up with another question. Now, are you 41 years old? Covey, because you took 6 years. Is that correct? Yes, Eli. How did you know? I am
math
now
checks out.
41 years old. But a cool thing is that I actually made a friend, and this friend made a time machine. So I can step into the time machine and look young again, because my face glows.
Yeah.
So
does.
that's how that works.
I thought it was just moisturizer.
Moisturizer too. That really, really helps with the anti-aging effect, Yeah. Another question that we had, I thought was very, very interesting, is can I look at the solar or lunar eclipse? Cole, do you know by chance?
Very, very good question, because we love to talk about safety and how to, when we're doing science, when we are observing things, when we're doing experiments, we want to keep ourselves and others safe. So the answer is, would you ever just stare up directly and look at the sun?
No.
Hopefully you're thinking no. So the same answer applies to solar eclipses, because if you stare directly at a solar eclipse, it's the same thing as staring directly at the sun. Now, the reason that we don't want that to happen, we don't want to stare at something that is as bright as the sun, is because we can essentially get what is sort of like our sunburn on our eyes. We can get damage to a part of our eye called the retina, and that could lead to some vision problems. That could lead to a lot of different issues in our eye. If you've ever accidentally, and this has probably happened to everybody, looked at a bright light or the sun for even just for a split second, you'll notice sometimes you'll see almost like these weird colors that are floating around your eyes. So that's what happens if you only look at the sun for a fraction of a second. So you can imagine how bad it would be if you looked at it for a really, really long time. So you have to be very, very careful when a solar eclipse actually does occur. They have special solar eclipse glasses that you can actually view through that take a lot of the energy and the harshness that the sun is spitting out and cut it away, so you can actually look at the solar eclipse without damaging your eyes. So do not look directly at a solar eclipse.
Nope, don't do that. Wear your glasses to
Yes.
protect yourself. Very good. Next one comes from Chloe. How long did it take all of you to get to space?
Oh, good question.
Wow, Chloe.
Well, I know that it took the farthest, before us, the farthest that humans have ever been in space has been, do you guys know?
No.
The moon, right?
Oh, yeah.
The moon.
yeah.
We've been to the moon. And that takes about 3 days. And I know for a fact that with our current technology, at the speeds that we can currently travel, it would take from Earth to Pluto, which we know isn't a planet, but it's a dwarf planet, the edge of the solar system. That would take about 9.5 years
Wow.
to travel that far. And that's with the
Crazy.
fastest craft that we have. And that's actually just talking about an unmanned probe, which probably goes a lot faster than anything that would have humans in it. So who knows how long it would actually take if we had humans. We'd probably have to, we'd be sleeping for a while.
We would.
That's a lot of sleeps.
That's true.
Uh-huh. Yeah.
Lots of sleeps.
Yeah,
Yeah, it's
yeah,
been
yeah.
it's been a long journey. Last few questions. Did you know that a day on Venus is longer than a year on Venus? From the Hayes brothers. Yes.
That's so cool.
That's very cool. Wow. Thank you
you.
so much. And last one from Rhythm. Are comets as cold as dry ice? Vanessa, do you know the answer?
Great question, Rhythm. No, comets are not as cold as dry ice. I would have thought it'd be the other way around, but actually, the average comet is around negative 70 degrees Celsius, which is still insanely cold. But dry ice is actually around negative 78.5 degrees Celsius. So dry
Ooh,
ice
very
is
close.
colder.
We'll see you next with my other friends back on Earth very, very soon. Bye. Thank you so much.
See you later.